Welcome to our case study challenge.
This is my sister Mackenzie, who during her sophomore year of high school began to experience strange symptoms of excessive thirst and frequent urination. Additionally, she began to notice sporadic energy bursts followed by phases of exhaustion. Over the period of several months, Mackenzie drastically dropped in weight. She was admitted to the hospital after suffering cold symptoms for 2 weeks, where she was administered a blood panel to determine potential causes of her symptoms. What did the blood panel determine?
So Mackenzie was diagnosed with type 1 diabetes mellitus, also known as juvenile onset diabetes. Over the period of these several months, Mackenzie's pancreas slowly began to lose its ability to make and distribute insulin into her blood. Without this insulin, Mackenzie's body was not able to provide itself with the energy needed for certain tasks. Instead, Mackenzie's body entered a state of ketosis, the result of her body breaking down fat stores instead of glycogen to meet its energy needs. Ketones released into the blood can reach toxic levels, resulting in ketoacidosis.
Insulin is a hormone that triggers cells in the liver, muscle, and fat tissue to uptake glucose from the blood. This glucose is then stored as glycogen in the cells. The storage of glycogen stops the use of fat as energy.
This diagram is a comparison between a healthy and malfunctioning pancreas. Type 1 diabetes destroys pancreatic beta cells, which is most likely the result of autoimmunity to one or more components of those cells. In some cases, insulin is mutated or inactive. Malfunctioning pancreases are treated with artificial insulin to replace what the body doesn't produce.
The insulin shown in red binds to the receptor shown in blue, allowing for the message to be passed. Two copies of the protein chains come together to form the receptor site that binds with insulin. Two hormones are responsible for this signaling, insulin and glucagon. Insulin only binds to one side of the receptor. When blood glucose levels fall, alpha cells release glucagon, and when the blood glucose levels rise, beta cells release insulin. When the insulin binds to the receptor, it is thought to cause a change in the shape that is propagated into the cell, activating the tyrosine kinase, as shown here.
Pancreatic islet beta cells are responsible for signaling insulin secretion. This is the point at which the pancreas with someone with type 1 diabetes mellitus malfunctions, causing no secretion of insulin whatsoever.
Diabetes can be managed by replacing the insulin. Insulin from pigs is relatively close to human insulin. The only difference is in one amino acid, a threonine amino acid in human insulin and an alanine amino acid in pig insulin, shown here.
This concludes our case study challenge.